right, thank you, Jeff.
All right.
Let's see, so we'll touch on a couple tips for modernizing testing labs, some things we've seen over the recent years. Automated testing equipment, working to streamline testing processes by reducing the need for manual intervention. This would include perhaps automating the cycle of test coupons through a test frame, automating calibration or test pass-fail criteria. So the data analyzation portion of that is handled automatically. And then, of course, different monitoring controls and process management, trying to streamline some of those items. Wireless data collection, this has been more popular, has a place in some applications and perhaps maybe not for other applications, but wireless is a good option for people that either need to get away from a corded solution or that physical connection is a challenge in the specific lab or testing site. Cloud-based data management, we've seen people more and more where they're exporting data up to the cloud and people can access it remotely. This is very nice if you're working with large amounts of data or have disparate lab locations that need access to that same data, or perhaps it's a way to share data in a protected manner with your testing partners or your customers. So you have data that's accessible to them, either real time or after filtered review, that they can access remotely. Machine learning and AI. So some things that can be done here. Essentially, they are analyzing data sets. They can look for patterns. They can make predictive analysis and decisions based on the patterns and analyzation from those data sets. This can be used to either improve accuracy or help efficiency, or even be part of a PM cycle where they're analyzing to make sure that they don't have any components failing. Other things you can do, automated bridge tracking for alignment. If you have a multi-bridge load cell and you see the bridges start to deviate from one another, that can be a trouble sign of misalignment or something else going on. Mentioned health monitoring for test abnormalities. Perhaps you have a DUT that's ready to break early, and there's some signs that may be popping up, so you can put some logic into your data acquisition or other devices to monitor for that premature failure. And of course, preservation of data, making sure you're capturing as much as you can. Remote monitoring and control, seeing a couple different aspects here. Number one, folks are building up systems that they can access remotely. So they'll have their test system up and running. They'll be at a remote location, able to monitor the test conditions, perhaps start, stop, pull data, analyze for system health. This again either allows for remote work or again locations with multiple labs with multiple locations, enables personnel from other locations to help or run tests from remote locations. And we've also built separate test and measurement systems that are designed to go on the road, where it's either doing remote monitoring real time, perhaps it's a battery powered data logger, or it's a rechargeable display system with load cells that are designed to go in a case to go on the road. So different options there. Multi-axis transducers, again, significant push here. People are trying to understand more and more about what's happening to the DUT in specific tests, and getting more data from multiple axes gets you additional insight for both design and model verification. And again, it could be simply from something as simple as how well aligned is my load string to what are the reaction forces being transmitted through this DUT.